right. We are live. All right. Got everything. Yep. Here we are. Little too far forward. All right, so we'll continue lecture. We left off with derived variables. All right, and we said sometimes this is the only way to work with our process of interest. All right? Sometimes we're going to have to take multiple variables and work with them all at once. So size. If we're looking at parasite communities and wanted to look at size, maybe we need to know not only the length of the individual, but overall, let's say, weights, so we can get a better idea of energy requirements. All right. Disadvantages, though, is that these things are relatively inaccurate, and the reason being is that our implied ranges for each of the variables gets carried over with every single calculation, and thus it affects the overall area. So if we have, let's say we have lengths and widths, that's what we measure, and we have lengths and widths to the nearest millimeter, let's say. All right, our implied limits are going to be at like the 0.5 level of the millimeter. So when we round to our whole millimeter, our implied limits can be anywhere from the half below to a half above. Right? But if we take a length times width to do area, we don't have that same 0.5 above and 0.5 below air anymore. We actually basically double the air width because we've multiplied. So to kind of demonstrate that, I have an example, surface area to volume ratios. All right, so if we had a surface area to volume ratio, and I said it was 3/5, all right? 3/5 is our surface area to volume ratio. We get down to 0.6, so that's 60%, and we would, if we just rounded it and said it was 0.6, that's what it was. It means that our implied limits for this is between 0.55 and 0.64. Okay? But that's not quite correct, because each of those, that 3 and the 5, each has its own implied limit. So the 3 has an implied limit of 2.5 up to 3.4. The 5 has an implied limit of 4.5 to 5.4. So in order to figure out our overall area, we have to think about what's going to be the smallest value that we can get and what's going to be the largest value that we can get. Well, the smallest value that we can get is when we take the smallest value of our numerator and we divide it by the largest value in our denominator, so 2.5 over 5.4. And then the largest possible value would be 3.4 over 4.5. And that gives us a range of 0.46 up to 0.76. That is a very different error than this 0.55 to 0.64. It's much, much bigger. All right? That's what our inaccuracy deals with for these derived variables. Surface area. So length times width, same idea. This is our 3 times 5. All right, let's do a surface area. Well, we get 15, and then you'd be tempted to say, well, our implied limits for 15 is 14.5 up to 15.4. And I'd say that's actually not correct at all. Because, again, each of these values, the 3 has an implied limit and the 5 has an implied limit. All right? And we would do the same thing. We look to see how do we get our smallest value, how do we get the largest value out of our implied limit range. So our smallest value would be multiplying the smallest values together. The largest would be multiplying the largest values together. So you can see, even though our surface area here would be 15, all right, our range, when we account for those implied limits, is actually 11.25 to 18.36. Very different. We had a 1 millimeter range all the way up to now, what is it, a 7 centimeter range of our error. So these are the things that a lot of people miss. I mean, even researchers are going to miss this big time. All right, they're going to do these calculations and they're going to say, okay, we have this is the error associated with it. Well, not quite. Because what you've done is each of your variables has error associated with it. But once you take that derived variable, once you start utilizing those variables in an equation, you've now just massively magnified the error that is in that variable, in that derived variable. All right. So disadvantage of them, yeah, they're relatively inaccurate. You have to realize the ranges that we're working with. Second thing is that normally these things don't follow a normal distribution. And we haven't talked about a normal distribution. We haven't talked about what it is or where it is. Let me say, the normal distribution is the bell curve. You've probably heard the bell curve before. All of our classic statistical tests assume that our data follows this normal distribution. All right? If we don't follow that normal distribution, then we can't really use classical statistics. So most of the time, these derived variables won't be normal. And thus we can't use classic statistics. Is that a major downfall? No, not really. I'm going to show you how we can work with it, how we can correct it. All right. Second, or the third disadvantage is that we're working with a derived variable, and that variable doesn't necessarily tell us about the relationships between the two variables that we utilize to get that derived variable. So lengths and widths, we use them to get a surface area. Well, we have a single number. It doesn't really tell us, is length longer, is width longer, is length and width positively correlated, are they negatively correlated? We don't know any of that information. The derived variable doesn't tell us that, and sometimes those relationships are important to know. And lastly, these frequency counts might not actually produce a continuous distribution. All right, so example here is dice. All right, so you have a single 6-sided die. You can get any value from 1 to 6. 1, 2, 3, 4, 5, 6. Right? What happens if we go to play craps? How many dice do we roll at the craps table? 2 dice. All right. So each of the individual dice can be 1 through 6. When we roll 2 dice, what are our possible outcomes? 2 to 12. What happened to 1? Can't get it anymore. Can't get it anymore. All right. It's impossible to obtain that 1 now because of what we've done. And there's other examples as well. So, multiple values can generate the same ratio. All right, so with that 2-sided, when you roll 2 dice, there's 6 different ways to roll a 7. 6 different ways to roll a 7. All right, but there's only one way to roll a 2 or a 12. All right, these are funny things that happen when you work with some of these derived variables. All right, now the solution to all of this is to transform our data so that we can work with it using classical statistics. And the one that I put up here is to transform it to probits, which is an inverse normal probability. Are we going to do this? Nope, absolutely not. This is in here just as an FYI. But it's to prove, or to show you that even though we might violate some of these assumptions, there are ways to fix it. There are ways to analyze the underlying data if we really want to analyze it. All right, questions on these derived variables? All right, so now we're going to get into the fun stuff before we take a step back and look at probabilities again. All right, so when we analyze data, one of the very first things that we do is visualize the data in some way. We look at it. All right? Not just looking at numbers. We want a graphic. We want to make a table. What we're interested in is looking to see if the data produces some sort of visual trend or gives visual clues about the question that we're interested in. All right? So what we typically do is go one by one. Each variable that we've collected, we analyze them individually. All right? And this is where I say, we're going to have one display per variable. And the display is going to be either a histogram or a bar graph, or it could possibly be a frequency table. All right? Maybe we're interested in correlation between X and Y. And you might ask, why would I look at X individually? Why would I look at Y individually? Well, we do it for a couple things. One, are the data normally distributed? We can kind of take a look at it and just get a ballpark estimate based on what they look like, what the histograms look like, if we're normally distributed. Number two, it looks to see if our data are skewed. So if they're not normal, it could be kurtotic, so peaked or shouldered, or it could be skewed itself. And we're also looking to see if we can see bimodal or multimodal distribution, so if we see multiple peaks. And I'm going to say the last thing that we're interested in, is not necessarily up here, is that we are looking for major outliers. And we're not going to really test for outliers. What I'm talking about here is we're looking for coding problems, data entry problems. Because if all of your data, if all of your measurements are going to be between, let's say, 5 and 13 millimeters, and then all of a sudden you have one value that's at 100 millimeters, oops. If you look at the mean, that's not going to tell you anything. If you look at the variances, you're not going to see that. But if you do a histogram, you've got all your data points here, and then this one really far out there, that's way out there. Hey, you screwed up, go back, get it fixed, then we continue it. All right? So when we make these figures, what we're really doing is looking at frequency distributions just so we can inspect our data. All right, so what's a frequency distribution? A frequency distribution is an arrangement of classes of observations with the frequency of each class indicated. Now our frequencies can either be a raw count or a percentage. All right, we're going to work with both. Raw counts are typically fine unless we're trying to overlay some curves, and then we probably need to do percentages. All right. These frequency distributions are going to be displayed as either a table or a figure. Now with the table, we're going to be making a frequency table that is also called an enumeration table. All right. I just use frequency table. That's all I'll use. The figures that we make are going to be a bar graph or a histogram. Now these are not interchangeable at all. So I did the or between them. All right. Histogram is for continuous data. Bar graph is a graphical version of a frequency table. That's all it is. So two different things basically. Preferred methods: histogram for continuous data, frequency table for all other data. All right, so posted. I have two data sets. I have qual frequency table data. All right, qual frec table data.csv, and I have a quant freq table data.csv. So we've got qualitative data and we have quantitative data. All right, go ahead, make sure you download those off of Blackboard. Here's going to be a good check. All right, so you can have your R markdown open. This is still the data and biology stuff. All right, make sure you download it to your computer and know where you saved it. And then I'm going to ask that you read it into R. All right, and when you read it into R, I'm going to ask that you call the qualitative data qual data, so that way it matches. All of the code should work. All the code that is in the presentation should work. And then when you read in the quantitative data, call it quant data. All right. And what we're going to do is once you get it in, I'm going to show you how we can make some of these figures and talk about general rules for it. let's get it in. Right. Save this document. All right, so got my data sets in, and so I went back to my data in biology. All right, so what we're doing is figures in R. These aren't going to be the only figures that we'll make. We'll make more throughout the course. All right? So basically, anytime we get a data set to analyze, one of the first things that we do is make a figure. We inspect the data. We want to see what it looks like. All right, so I just have a subheading, reading in the data, just kind of get it in there all at one spot. So I used my import dataset button. From text space, I found the file that I downloaded and saved, hit OK, and then I took the code, copy and pasted it up into the actual chunk. All right. Now, don't forget, when you import these, that checkbox that says strings as factors should be checked. All right? Really? Should be checked. All right? And I think the other option, I think there is a strings as factors equals t. I think Alex had it. He pointed it out. Remember that? Yeah. Strings as factors. Oh. All right, so we have it in. Hopefully you had it in. Hopefully it wasn't too bad. All right, so let's talk about things that we can do. So one of the things, I know RStudio will automatically show you the data set. Opens up a tab and shows the data set. There is an option that turns that off. So sometimes if I have that option off, what I might want to do is just make sure that I have the correct data set in. So one of the commands that I issue is head. So head gives us the very top of that data frame that we have. So we imported the data set, it read it in as a data frame. I called that data frame qual data. All right, so the head function just gives us the top 6 rows or so. Now, if we had multiple columns, we would be able to see multiple columns on there. It shows us the variable names, shows us what's in there. Somewhat useful, but again, RStudio is by default. We'll open up a tab and show you your data set, so it's less important. What we want to know is we want to create a frequency table. So this data set represents the model of car in a parking lot across campus. So I think maybe the commuter parking lot here by the greenhouse. All right, go out there and you just recorded what is the make of the vehicle. And it just so happened that we had 55 total cars out there that were sampled. So we went through, and each car we just kind of went down. You know, row 1 it was a Chevy, row 2 was Chevy. You know, of course this was sorted, but we've got this table, and what we want to do is look at a summary of it. So how do we do that? Well, we issue the table function. All right. Now the table function needs a vector. All right. We have to pass it a vector. So how do we pass it a vector? Well, if you recall from that introduction, that vector that we're interested in is this column. This column is located within a data frame. If we just did table make, R wouldn't know where to look. So what we have to do is tell R where to find that make variable. Well, where is it? It's in the data frame, qual data. So we use our $sign notation to do that. All right. So I'm going to bring this over. There. All right, so we are going to make a frequency table. All right, so we're going to make a frequency table. The function is table and our vector of interest. So our vector is in a data frame. All right, so I'm going to specify and say that we must use this data $vector format to reference it. All right, so we want to look at the frequency table of make of cars. So I'm just going to go down into my chunk, table, call data, $make, hit enter, and R gives me the frequency table. Now this works great for viewing the counts, for viewing frequencies. Maybe you're looking at fruit flies and looking at their phenotypes. This is great for doing that. All right, but this really isn't publication quality. Right? Would you say that's publication quality? Nope. So how do we make publication quality tables? What do you think?
Excel.
Excel. Exactly. Someplace else. R did the simplification for us. It actually tallied up every single make that's in there. All right. It gave us the raw data. So now what I would do is actually go to Excel and make that table. So, Excel, no, and I will enlarge. Here's my Excel spreadsheet. All right, it's as easy as saying we have make and our count or our frequency. All right, so what we're going to do, 5 makes and total. All right, so with frequency tables, it's often good to include a total. So you can either have a total row or you can put the total in the table description. All right, like the table 1, frequency of cars in the commuter parking lot, and you could say n equals 55. All right, but having the total is important to know. All right, and then how do we arrange our actual makes? How you arrange is kind of up to you. General rule is to put it in some sort of order, an order that makes sense. So for the makes, it's probably sensible to put it in alphabetical order. So we can do Chevy, right? Ford, GMC, and then Toyota. And then we also have this other column. So that's kind of the interesting part. If we have another column, then by general rule, the other column goes at the bottom. All right? And then I just have to add in my counts. So it's 12, 15, and 15. All right, are we done yet? Nope. Still not done. All right. It's my shortcut. My shortcut's not working. Maybe that's only for LibreOffice. But what I would like to do is get it centered. All right. I'd like to go back and make our header rows bold. All right. Maybe make the total row bold. But other rules is to have borders. Where's our format cell? Normally, we do a border at the top of the table and at the bottom of the table and between the header row and the body of the table. And here we're at the bottom of the table. And if you have a total row, normally you put a line that separates the body and the total. We don't add lines between every single row in our data set. That's just a no-no. the journal will kick it back to you and say unacceptable. All right. Is that good? You might think it is. I despise Calibri, so I would probably change the font. But if I use Calibri in my entire paper, then you better bet that this will be Calibri in this table. You graduate students and anyone doing an undergraduate thesis, make sure your footer, your page numbers are the same font that you use in the paper. Vast majority of them are different, and I can spot them. All right, so it's pretty easy. Ours has a simple command. Table gives us a frequency table. Then we can take those data, transfer them right into Excel. Could we do the same thing in Excel? Yeah, there's pivot tables that we can make that would give us a frequency table. But quite frankly, I don't think it's as easy as R. I think R is very simple just to have a one word function table. That's all it is. What if we have two variables? Can we do, a frequency table that has two categories in them? Yep, we'll do it. We'll look at how to do it. I should say, I hope to do it. I don't know, with one less week, it may be hard to get there. All right, so I did include everything here, table construction advice. So again, if you don't include a table row, make sure you have your total sample size probably in the table caption. What happens if alphabetical order doesn't really make sense? So let's say you did counts of, roaches in this building that we see, and we group it by months, all right? It doesn't make sense to alphabetize months. It makes more sense to kind of group it in their natural order, right? Monthly order. So that's why I said I didn't say alphabetical, it's just logical order. Put it in some sort of logical order. What about quantitative data? Well, we can do the same thing. We can make a frequency with quantitative data. Are we going to do it when we have continuous data? Probably not. Making frequency tables is probably better for discrete variables. So those variables whose options can only be whole numbers. All right. So we have quantitative frequency table data in. Right. This data set is recording the number of plants found inside of a square, a quadrat that we draw. All right. So think of the experiment as this way. We have an area out in the quad, the size of this room. We've got little 1 foot by 1 foot square grids. We go out there and pick random points and we drop that grid, and then we count the number of plants, maybe the number of weeds, a specific type of weed in that grid. So our data set represents one grid, each row represents one grid, and then the count is how many of those weeds are in that grid themselves. All right, so it's just a fairly big, long data set. What we want to do is summarize our data and look at the frequency tables. So hopefully if you make it, you just use your table, quantitative $plant. Now I use the names function here. What does that names function do again? Yeah, it's going to show you what the variable names are in that data set, right? That's what it's going to do. So here, again, if RStudio wasn't being used, if you instead were just using the regular R console, right? You imported your data set and you needed to know what the variable name was. Names can get us there. All right, and then I issued the table command. Same type of thing. R gives us a very easy output. It saves us from having to go down and manually count up how many of them equal to 0, how many of them equal to 1. It saves us the trouble of using the COUNTIF function in R, or in Excel. Where the COUNTIF function, we can set up a requirement and say, count if our value equals 0. Count this row if it equals 1, and so forth. All right? We have to do that function repeatedly, all the way up to 9, whereas in R, we can just say table of this vector, and I get this frequency table very, very easy, very, very quickly. If we're going to graph it, or make a professional-looking table, I do it the same way. I get it into R, Right? I take the R data, I get it into Excel, and then I add your lines, I center it, I bold it, and so forth. All right. Here, though, you'll notice that I use 9 plus in my table. Is 9 plus. And there's a reason, because when we're counting these plants in a grid, all right, yeah, we counted 9 plants in a grid, but there could have been more. All right, there could have been more. So we recognize that we could have counted more than 9 by saying 9 plus. Also, if we're doing this, maybe we had a grid that had 12. Maybe we had a grid that had 20 of these weeds. So instead of having a bunch of numbers with zeros, what we can do is condense or collapse groups to this 9 or more category just to increase our counts. This is important when we're doing like a chi-square goodness fit test, and we're trying to fit a distribution where you really can't have zeros. So again, this is something that we get into fairly early on in the grad class. Questions? What about bar graphs? So bar graphs just basically take your frequency table and make it into a bar graph. All right? So the bar graphs, their information is conveyed by the area of the bar itself. All right? You'd think it's the height, but it's actually the area. That's what we perceive, and that's how we kind of conceptualize it. All right? So with these bars, we always have to start at a 0. Our y-axis should always start at 0. If for some reason we're dealing with a bar graph and we're up at the hundreds and then the numbers don't correspond to the 0, we've got a problem. Somebody's hiding something from you. All right? Our bar graphs always have to start at 0. All right? And we only use a bar graph when working with qualitative data, when working with frequencies. We don't ever use a bar graph for averages. We don't ever use a bar graph to display medians. Right? We do it for frequencies, and why is it for frequencies? Because frequencies could be a 0. It's 0 all the way up. All right? So how do we make this? So the bar plots needs a table of frequencies. That's our command. Right? So or that's what we have to give it. So it's kind of a two-step process. All right? We first make the frequency table, and then we take that frequency table and pass it to the bar plot. Now, it's a two-step process, but we can write it as a single line of code, because R will start inside and work its way out. So instead of having us make that table first, and then saving the table, and then refeeding it back into the bar plot function, we can just make it as a bar plot. So let's see what's going to happen here, because I've got extra code up here. All right, so we made our frequency table. I'm going to say, whoops. All right, so I'm going to put up here where we repeat for quant data, and now we are dealing with bar plots. I used 2 or 3. 2. Making a bar plot. Bar plots are for qualitative data only. I'm going to put this in bold. And in capitalization. All right. May be okay in other classes to do that, but in this class, you cannot do it. Bar plots are only for frequency table, for frequency data. All right, so the function is bar plot x, where x is a frequency table, or vector of frequencies. All right, so I put both in there because what it's looking for is actually some sort of vector that's showing our frequencies. All right, so I have my counts up here. I can see my Excel of the car, of the makes. All right, so what I can do is do bar plot, and I'm going to make a vector of our counts: 7, 6, 12, 15, and 15. All right, that's our table of counts. And when I make it, you will see that it generates a bar plot just fine. But we have things that are missing. We're missing our labels. We don't know what any of these bars correspond to. So if we have just a table of numbers, we have to manually specify what each of these bars corresponds to. Could we do that? Yeah, we can do that. I can show you how to do that. But we already have the raw data. We already know what, we have the raw data. We have that vector of data that will go through and do our counts for us. So let's issue the table command on our qual data $make. And now notice what happens. Now the labels get added automatically. So when we issued the table function and created this frequency table, it lined up each of the numbers with the make itself. And then once barplot received it, it said, hey, I not only have the numbers that I need, but I also have the labels, and I'm going to make the graph just as you asked me to do. This is a bar plot. A lot of our same rules apply in terms of ordering. Is this the order that we want? No, where's other? Yeah, it's not at the end. So how do we fix that? How do we fix that? All right, bonus will be at the end. How can we reorder their factors, or I should say levels, so that the categories appear in the order that we want? We're going to use the factor function. And that's why I had it up here. I had it up here on the presentation so you can actually see how we do it. How important is it for you to remember it now? No, not very. That's how I put it as a bonus. All right? Could come into play later on if we're looking at putting things in specific orders. Definitely in a graduate level course, we should know how to do this because some of our post hoc tests, it relies on us having it a certain order. All right. But for now, this is how you handle it. It's kind of like your months. If you keyed in your months with their actual name and then you plotted it, you're going to have what? April 1st. You're going April is the very first column. What's next? December is second. I mean, they're going to be all out of whack. How do we get those orders specified? Well, we're going to use the factor function. All right, but not just that. We're going to use factor. We're going to give x is our variable. All right. Then we have to specify the levels. All right, we have to specify our levels. And this is what I did here. Factor levels. All right. So here we've got, so where x is our categorical variable, and we provide a vector of our levels in the order that we want. All right, so here's our example. What we're going to do is factor, or what I will say is a refactor. All right, we're going to refactor this variable. And what I mean by refactor is that whatever we're going to do, we are going to save it back into that same variable. All right, so the factor command is going to do it once and then R forgets it. We don't want that. What we want to do is do it once and then save it. And one way in which we can do that is to save it back into the factor, the exact same column, in the exact same data frame that we've been working in. Thus, my refactoring. We're refactoring it, and we're going to save it. So qual data $make. We're going to save everything back to that. All right? So we've got factor. We want qual data, $make, and then our levels. All right? So qual data, $make, and then our levels. What levels do we have? Well, I can see them up on the board. All right, and we want them to appear in alphabetical order with other at the end. So these are strings. So, oops. So what we're going to do is use quotation marks around these values, these levels. So levels, Chevy, Ford, GMC, Toyota, and other. And it's important that these levels appear exactly as they appear in your data set. You can't, they have capitalization, spelling, everything has to be exact. And this is something you may find if you get your data into Excel first and then import it into R, that you may have added an extra space in one of your values that you recorded in Excel. So there actually may be two GMCs. And you're going to say, how do I have two bars of GMC? Well, one of them had an extra space, either a space before or a space after. Now, normally, I believe that things have gotten better with Excel to delete all of those spaces after, but you never know. It could be screwed up. So we have to have our list, our vector here, include the names exactly as they appear in the data set. And then when I save this, or when I run it, all right, what I've done is refactored our variable. So when I go back, all right, I'm going to grab my refactored data set now, and instead of retyping it, I'm just going to copy and paste. It appears in the order in which I want. All right.
In the PowerPoint, you also included order equals F. Is that
Yeah, so the ordered equals F is kind of gives it if we are ordering our variables, if it's ordinal variable, if it's ordinal data. Do we necessarily need to do it? No, we don't. We can just leave that off. We just leave it off.
Mine are in the right order, the bars, it's just flat line.
Uh-oh.
Yeah.
Uh-oh.
From 1 to -1 on the bottom, and they're all
Yeah.
valued the same. Well, if you rerun it.
Okay, so what you'll have to do is probably reload it. Go ahead and type in qual data down there, down there, and hit run or hit enter. Yeah, so something messed up. So let's go check your factor command.
Yeah, I messed up.
Everything was looking good until you ran this one. Did you run that twice by chance?
I did. It didn't work the first time, so then I reordered it.
Yep. So go ahead and just go back up
to where you read that data in, on the qual data, so you don't have to go through, you just run the chunk. Oh, you didn't copy and paste your command that you used to import your data set? All right, you need to do that. So go back to your history and you should be able to find it. And then you can do your history. So we had one. Now I'll go up here and bring it up because some of you may also run into this. If we screw up, so I'm going to intentionally screw this up here. I don't know how to screw it up. I don't know if that's going to complain if I don't do that. How about this? Let's add an S by accident. Let's see if that changed it. No, I don't know how you messed that up. So that what happened was when this command was run, because we're taking data in a variable, adjusting it, and then saving it back into a variable, if the code isn't run properly, then what's going to happen is it's going to eliminate, basically delete everything in that column. Delete everything in that column. So this one's going to still run. Man, do you know what you ran? Let's look at your history real quick. See if I can replicate it up here. Oh, you got that already? Mm-hmm. You'll do the quant data there as well. That one didn't work. No. Did you else? Okay, let's try this. Let's try this. Here's I think this is what happened here. So you put quotation marks around the entire list instead of around each individual items.
That's what I did at first.
That's exactly what you did.
That's
so watch what happens. So I ran it, it works, you think it works, and then you make a bar plot and oops. Alright, what happens? Alright, so what this factor command is doing is going into here, into the make, alright, and it's going to take all of our factors and get them reordered in memory, alright? And the reorder in which it's looking at is this. It's reordering all of these, but this is all in quotation marks. So it's looking for this entire thing, Chevy, Ford, GMC, Toyota, other, alright? And if it doesn't find it, it lists it as missing data. It's not in our list of factors that we're trying to examine. So when I go down here and say, okay, well that's not right. Let's look at this qual data. Whoops. Qual data $make. You will see that this outputs just a bunch of NAs. So we've taken values that had names in it and just deleted all of them. So it's missing data. And then we try to make a table and make a bar plot of missing data, and it's all messed up. It's all messed up. Now, it still knows that we have levels. The one level that it's looking for isn't a Chevy level and a Ford level and a GMC and a Toyota and another level. It's looking for that one level. It's just we don't have that one level in our data set. So how do we fix it? How do we fix it? The only way to fix it is to go back to our chunk where we read in our data. What happens if you didn't save it? I'm going to go up to history. This is a history of all the things that I ran. There's my data right here. Qual data. That's the code that I want. All right. Now, when I right click it, I don't have the copy anymore. But what I can do is send this over to my console. Okay?
right here. So it's highlighted. I'm going to send it to the console, and it pastes it over here, but it doesn't run it right away. So right there, I can now take this, copy it, and paste it into a chunk so that when I run this, it's automatically importing my data set. So I'm going to hit play, fixes my numbers. All right, let's go back and get our refactor set. So quotation marks around every single item here. So now we've got 5 different levels. All right, we've separated each by a comma. I'm going to run that as a refactor, do my bar plot, and voila, we've got it. All right, this won't be the only time that this happens, guaranteed. All right, but this is how we can fix it. This is how we can fix it. All right, any questions? Did everyone get this? Did the refactor work? Get it work? If you didn't, hopefully I showed you how to get this fixed. All right, so bar graphs. All right, so I say it's only for frequency count data, and really it's because the space between the bars emphasizes the heuristic quality, the categorical nature of our data. All right. All right, so it's 2:55. Let's see here. Yeah, tell you what, I think we'll stop here. All right, we'll stop here and we'll introduce histograms on Wednesday. All right, and then I think I have a homework assignment that will be going live that has you doing some of these things, making a frequency table, doing a histogram, and so forth. All right. So if you have any questions, feel free to ask me now. You are free to stay here if you want. If you just want to take off, you can. Right now, we don't have any homework assignments. But we will, just kind of additional practice. All right. Don't forget to save your RMD file. What's that?